Welcome, guys, to part 2. So let's continue where we left off. So let's see what we need to do now. So we were having that error before we left. The voting analyzer, it doesn't know what voting grid is. So we're gonna need to do a forward declaration. Voting grid. Forward declaration. Forward declaration, right? And then we're gonna debug again and see if we have any bugs. Build finished. Yeah, it exited with 0, so we have no bugs. We have no more bugs. We are good to go. So now, remember that this is a virtual function, right? And it's going to be implemented differently by all the child classes. They are the ones that are going to implement this. So what I'm going to do is I'm going to copy this function. Okay, I'm just going to copy everything from public. I am that lazy. Remove this, potential, remove that, battleground, a tab, there we go. And then I'm gonna need what we call the analyzer, potential fraud analyzer, this one, predicted outcome analyzer. So there we go. Bam, bam. Then predicted fraud analyzer, potential fraud. There we go. Done. So I shouldn't make it a pure virtual function anymore. It's not pure because now these classes are going to implement this function, right? So I need to remove the equals to 0 so that it doesn't become a pure virtual function anymore. And then let's see, the voting grids analyze method must now polymorphically call each of the voting analyzer functions and return their combined outcome. Okay, let's see. Okay, before we get to do this, let me highlight it. We're gonna check the other information. So let's see what we're supposed to implement here. So add the following to your voting grid class and overloaded assignment operator. So we need to add an overloaded assignment operator. So those three are always there: the copy constructor, destructor, and assignment operator. So you must return back a voting grid reference. What operate, and then I use the operator keyword to say that I'm creating an operator. And then it must take in another const voting grid by reference. There we go. We have our assignment operator. And then I'm gonna need to add, what's the other operator? Support for the use of the exclamation operator. So the size of the grid stays the same. The ID stays the same. The population is set to 0. The support percentages for the two parties are set to 0. that decided what factor set to 0. So for the operator, I don't think you're gonna need, what is this? I don't think you're gonna need any return type because it clearly doesn't return anything. Yeah, I think it's just gonna be some void operator. This, and then that's pretty much it because it's not gonna return anything. Let's just double check, but it's not gonna return anything. Let's check the textbook. Let's see. Operator overloading. Yeah, it's not gonna, definitely not gonna return anything. All it's meant to do is just mutate or update the date. That's all it's going to do. So let's check. Let's keep scrolling. Duh, 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 duh. Where is this operator? General syntax for overloading the binary arithmetic. Okay, we're not overloading the arithmetic operator. Binary operators, no. Has none, no. That's not what I need. I don't want the stream insertion, stream extraction. No, we don't want that. General syntax for the, what is this? Where is it? Yeah, unary operators. Come on, come on. Post increment, nope. Well, I'm just assuming we're just gonna write it like that. Because if you check the other ones, for example, Boolean, obviously you must take in another object to compare it with. That's gonna return a Boolean. And then you must also return const because it's not meant to change. And then, yeah, I think that's pretty, I don't see it here. But I think, yeah, you don't, because if you look at the code, we're not adding, we're not subtracting, we're not doing anything. You're just gonna be a void. You don't do anything. You don't return anything. Because the main goal is for us to like negate. In a way, that's a symbol for negation. So for example, when you say bool is large, then you set this to true. So when you say is not, this translates to is not large. And large is true. So basically you're saying is not true. What is not true? It means that is false. So that's what it's usually used for. But in this context, we're not using it in that way. We're not gonna expect any returned value. So I'm just gonna make it a void. Yeah, I'm just gonna make it a void. And then I'm a support for double indexing by the way of a overloaded function invocation operator. So after indexing, you get back a value, right? And what am I getting back? Remember, it's a two-dimensional array. It's this voting district. So I'm gonna get that voting district back, and I'm gonna get back its reference instead because you don't want to, you want to make your program really fast. So I'm gonna return that value that I'm getting back by reference. Because if you remember at the top, at the beginning, they say that you must create a two-dimensional array to represent what? Voting districts. So that means at each index or each coordinate, each row column coordinate, the value is a record structure. That's what it means. So I'm gonna say operator. What operator am I using? The invocation operator, and then I pass in the arguments. This is the signature. It's gonna take into values, the rows and the column. And since I'm expecting it not to change anything, I'm gonna put a constant at the end. If you just like if you remember getters and setters, when you say get rows, const, something like this, right? So it's the same thing. This is actually a getter. So I need to put that const at the end to say that, listen, this is not meant to change, meant to just access. I'm giving it access privileges, but not mutation privileges. You can't mutate or change the data. So there we go. That's everything. So what I'm going to do is open here. I want to check something. Additional topics. Nope. 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 Where's this thing that I'm looking for? Okay, I want to check something here. Nope, nope, nope. Okay, I don't see it here. We'll get back to it. I don't see it here. What I'm looking for. Load. Okay, so let's continue. So add a member function to the voting grid class, which will load the information from the provided text. So I'm gonna call it load from text. I'm gonna call it, it's meant to just load, right? So after loading, get a member function to the voting grid class to load the information from the provided text. Yeah, from the provided text. So I'm just gonna make it a void, and then I call it load from text, and then it's gonna take in a string. That's gonna be its signature. It's gonna take in a string, the file name. That's what it's gonna take in. And then what else do we need? Add a member function for voting grid, which will save the contents of the two-dimensional array to a binary file of records. So we're gonna need to save this to a binary file. So it's the same thing, literally the same thing. Save to binary, and then takes in a string. Takes in a string. There we go. That's pretty much it for now. In all cases, the functions will take the name of the file as the parameter. Yeah. And close. Yeah. So we do take in the file names and all of that. So yeah. So far, that's all we had to do. So yeah, let's implement these functions. So I'm gonna start from here and go up until there. I'm going to voting grid.cpp. So I'm gonna open voting grid.cpp and then say hash include voting grid.h, and then there we go. Now I need to state and specify in which class this information is coming from. Voting grid. There we go. There we go. We have our operators. There we go. And mind you, I'm putting this line of code next to operator equals, because that's the name of the function. It's operator equals. That's the name of the function. And then operator exclamation mark. That's the name of the function. And then load from text. That's the name of the function. And then that's analyze. That's the name of the function. And then this one, the destructor is, the name starts from the tilde. So now we need to implement the code. So I need to also add a couple of things like the constants. I need to add constants. So now I need to add constants because I have a default constructor. So let's define them. So now I need to go back to my voting analyzer.h. No, voting grid. There we go. That's voting grid. I need to add my constants. So plus constants. So let's add them. So remember the way you create a constant. You say const to specify the const keyword to specify that this is a constant. It's a value that's not going to change, followed by the data type of that constant. So we are working with an integer, right? So the data type is going to be unsigned, right? And then I'm going to have minimum. Um, let me see. I'm going to create constants for, let me think, for what? For the rows and columns. The minimum value for each should be 0. You can just write unsigned, but I'm just gonna put that int there to specify that's an integer, but you don't have to do that. And I'm gonna make it static const to make sure that there's one copy. All the users, all the instances of this class will share, because these values are never changing, right? They're constant. I don't need to make each object have its own copy. Each object needs to have a different copy, the same copy, not a different copy. And then unsigned int max value. It can be some arbitrarily large value. Let's just say 100,000, right? And remember in C++, you can put the single code to space to split the digit in such a way that it's human readable. So I can do that. And if I wanted to make it 100 million, I can do it like that. But I want it to be 100,000. So I'm just gonna leave it like that. And then I'm gonna need, for the rows and columns, right? What other constant value do I need? Oh, for my grid, for my district, I mean. So for my district, since it's going to be a complex type, of which it's a record structure and there's another record structure within it, I'm gonna use const expression. So const expression, and then what's the type? The type is voting district. That's the type. And then I say is equals to what? I need to put in the curly braces if I want to initialize it, because there's more than one value inside this type. So I'm going to use the curly braces. And the first parameter, and then each value is initialized like this. So remember that the first parameter, or the first thing inside the record structure, it's another record structure. So it's a district ID. So I need to put another pair of curly braces there. So I'm just gonna start it as 0, 0. Okay, that should be fine. I should leave it like this. And then I'm gonna have population 0. Yeah, it's just gonna have default values. And then UAP, APU, so it's 3 double values, of which I'm not gonna waste time overthinking. I'm just gonna say is equals to that. Oh, I forgot to give it a name. Default district. Yeah, I don't know why I didn't think about it. Yeah, as you can see, it shows even all the parameters, all the values in the record structure. So it's gonna be defaults, all of them. So the default district, minimum value, max value, and then I'm also gonna need an enum for my error flags. So I'm gonna have an enum status. I'm gonna call it status, and then I'm gonna start with error in the range. Just gonna make that is equals to start at -2, and then error in, should I say -2? I think it can be -1, that's fine, because I don't think there's no command line arguments in this tutorial, in this question. So I don't have to worry about that. And then I'm gonna have, where is it? Where do I want to change it? Is it my main or what? Yeah, my main. So instead of it returning 0, I'm gonna make it return dot constant success. There's also one that's already defined. See, there's one that's already defined in the system. You see, inside the standard library for C, is for C language. You see, it's using the preprocessor define to make a constant. So it's a constant 0. But in order to showcase that I have my own understanding, I'm using my own. And remember what macros do, they can be trusted. They have unexpected behavior. And then now I'm gonna do constructor chaining. Well, I'm gonna need 3 types of constructors. I'm not done yet. You don't have to, but for the sake of good practice, you need to have 3 types of constructors. That's why I also have 3 different types of default values. And then the next value that I'm gonna expect is a voting district. I could take it by, I could take it by address. And then voting district. The record structure could take it up by address to make things faster. Let me do that. Let me take it by address like this. The immediates or the integers, they're fine. I don't have to, it's fast, it's just one value. When it comes to something that's complex like a record structure, I need to pass it by address to make my program faster. So now I'm gonna chain it to the constructor that is everything, which is this one. That is all the parameters. And then I'm gonna say min value. No, okay, minimum value and max value, that don't matter. That's something different. I need to create other constants for default rows and default columns. Default rows, let's say it's a 25 by 25. So static const signed int default underscore columns is equals to 25. Then, okay, I'm gonna remove main. Then I shouldn't be putting that one. There's default rows and default columns and the default district. Oh, okay, I see now. So it is going to complain if, well, I don't know about the address thing. Let's just remove it because now it's expecting an address instead of the actual value. So let's just leave it like that. But using the address would have been way faster. So I'm gonna have rows here and then columns. And then I'm gonna have another function that's quite useful. Okay, I'm gonna have quite a lot of useful functions because I have the assignment operator, this operator, and this operator is gonna use a lot of allocating and deallocating, all of that. So I'm gonna need quite a few helper functions here. So the first helper function I'm going to have is enforce range, to enforce the range. So it takes in integers. So it takes in integers, right? Yeah, so it's just going to take in integers, 3 integers. You shouldn't change the code, you should just check. So put a const there. And then I'm going to have a void destructor. It's a helper function. And then I'm going to have a void constructor. And then it's going to take unsigned int, unsigned int, and a voting district. And then void copy constructor const voting grid reference. There we go. So this helper functions are going to be very useful. So I'm going to put them somewhat at the bottom there, because they're mainly helper functions. There we go. Put it there, put it there. There we go. There we go. And put it there. And then let's start with the destructor. So with the destructor, I also have another thing that I need to use, which is also have some libraries that I use. CRSet library. I need to use the CSC standard library. And then what else do I need? Oh, the string stream. I might need that. I might need the string stream. Then that should be fine. So let's assert. So let's make sure what's the case. You can do the assert in 2 different ways. You can say, let's make sure voting the 2-dimensional array. Let's make sure it's equal to now or it's pointing to now. Make sure that's the case. No, you can no, it can be in 2 ways. If I say it's equals to now, that means it's going to be allocated. It's already deallocated. And to say assert underscore voting is not equals to now, that means it's not empty. That means it has some memory for me to clear or to delete. And then I'm gonna do a for loop. I'm gonna start from 0, then go up until the rows. And then we can do pre-increment or post-increment here. It doesn't really matter. And then I'm gonna delete. So delete what? Voting. Remember, voting is a 2-dimensional array like this, right? So it's gonna be a column here and a row. But I want to delete the columns array or the columns dimension. How do I do that? I remove that C there and then I leave it empty like this to indicate that I'm emptying it out. But the syntax is quite different. You don't put it there. You have to put it before or after the delete keyword like this. You have to do it like this. This is the syntax for deleting. And then you deallocate the remaining, the rows dimension. You put brackets, then just say voting. Now it's just voting because I was only left with this dimension. That was the only one left. So that's why there's nothing next to voting. And then I'm going to make sure my voting is now pointing to now. Then done. I've deallocated. And then I'm gonna need to work with to create the constructor. So let's implement the construct. So I'm gonna have rows here, and then I'm gonna have columns. I'm writing the variables here because I need a way to reference them. And then I'm gonna have district here. And then, okay, enforce range. So let's go back to enforce range. So I'm gonna have a value that I'm enforcing. Then I'm gonna have a minimum. Then I'm gonna have a maximum. So what I'm going to do is I'm going to say if the value is less than the expected minimum, then what should happen? You should output, okay, I'm gonna have more than one line, so I need to put curly braces. It's gonna, okay, I didn't say using namespace standard at the top. I need to do that using namespace standard like this. And then scroll down, we say C error, we use the standard error stream object. And then I say output what? Output this error. Value is what? Less than expected minimum of, and then I output the expected minimum in line like this. And then I call the exit function to exit when this is the case. Exit with error in range because there was an error in the range. And then I'm going to change this. Say if it was greater than the expected maximum, and then I change the text to say it was greater than expected maximum of, and then what's the maximum? It's max. And then I put in a new line character at the end. And then that's it. That's all I have to do with enforcing the range. Let me see. So the value is fine. I can put in any value. But when it comes to the minimum and maximum, it's going to be unsigned. If you think about it, it's just going to be from 0 and upward because that's expected from my program. That's what's expected. So I'm gonna go back. Okay, the helper functions are down here. And then I just write unsigned and signed. There we go. That's a bit better. Enforce the range. Done, done, done. Then now we have the enforce range function. Now we can implement the constructor and the copy constructor. So let's do that. So I'm gonna enforce range for my what? My rows. They should be they should be in what range? They should be from mean value, which is from 0 up until some maximum value, right? -1. Because if I'm counting from 0, I'm gonna stop at the number before the last value. So I need to subtract that 1. That's important. Enforce range, and then I'm gonna have columns, and then I'm gonna have mean value, and then I'm gonna have maximum value -1. And then there we go. As for the voting district, yeah, I also need to enforce the voting districts, the values, because it's unsigned. For example, the population is unsigned. The district ID should be unsigned. So let me rename this to district ID like this. Yeah, so the district ID values should be unsigned. As you can see, they should be unsigned. So I'm gonna do that. enforce the range for what? For my district dot district ID dot the row. It needs to be at least 0 and some maximum value, some arbitrarily large value. And then enforce range district dot district ID dot column, and then mean value of 0. It should be at least 0, and then up until some maximum value. So there we go. And then I'm gonna need to enforce the population and the UP support and all of that. So I'm gonna need to create a constant for this. I'm gonna call it static const unsigned double. No, it's not unsigned. It's a double. So a double is a const expression. Don't forget that. So double, and then I'm gonna say what do I want to call it? Support max value. The max value should be 100. So if it exceeds the 100, then we have a problem. So yeah, and the population should also be at least a value that's greater than a value that's at least 0. That's greater than or equals to 0, because you can have -1 people. You most certainly can do that. No, I don't want the district ID dot population from minimum value to some maximum value. Enforce range district dot APU support min value up until support max value. And it's inclusive of support max value, because they said from 0 to 100. If I subtract 1, it's going to be 0 to 99, which becomes wrong. So it has to be 0 to 100. So it includes that support max value, which is 100. And then I'm going to enforce the range for district dot UAP support min value, and also between 100. And the last one is also the same, undecided min value support max value. There we go. We've enforced the range. So the user cannot enter values that are not in the right range. So let's continue. Okay, I don't need to look at that now. Okay, just the construct, yeah. So now let me set the rows and columns. So underscore rows is equals to rows, underscore calls is equals to columns. And then now I need to allocate memory for the array. So voting is equals to new voting district. Remember, it's a voting district, right? And then it's a two-dimensional array. So since it's a two-dimensional array, must allocate memory for each dimension. So starting by the outermost point, the closest one, which is the one that's on the outside, I replace each pointer with square brackets, and the square brackets tell the compiler that I'm giving it a size now. What's the size? The size is of size rows. And then you can use columns first. Yeah, but just make sure you maintain the logic in your code. You maintain the same structure. So int r starting from r. Yeah, now I'm gonna use proper terminologies for this. I'm gonna make it unsigned. And then r is less than underscore rows r++. Because at the end of the day, rows is never gonna be positive. negative, so it's always going to be positive. So I'm just going to put unsigned there. And then I'm going to allocate memory for each row, give it the size of columns. So new voting district, and then remember that we've allocated for this pointer, right? I'm done with that pointer. Now I need to allocate for the next available pointer, which is this one. So I replace that one with square brackets. And then I say is equals to the size. I give it a size. What's the size? It's columns. And then now okay, yeah. Now I need to initialize unsigned. C 0 is equals to 0. C is less than underscore calls C++. Now I need to change. If you check, you're taking a default district value here. So I need to use that default district value. And then I say underscore voting RC is equals to that district. So at every single row and column is equals to that district's value. Because if you check here, it's where is it? Where's the district? Yeah, if you check here at every single coordinate, row and column coordinate, it's going to be of type voting district. So that's why this is possible. That's why that's working. And then I'm gonna do the copy constructors helper function. Object voting, obj voting. I'm gonna use that. And then what I can do is the copy constructor, right? So what I can do is I can make an assert that I make sure that you don't try to copy things that are not of the same size. So I'm gonna say that object that you're trying to copy from, it should be the same size as me. So it should be equal to object voting dot underscore rows, and then assert underscore columns should be equals to obj voting dot underscore columns. They should be equal. You can't copy things that are not equal. It should be of the same size. So I need to do that assert there, even though it's a shallow copy. But yeah, at the end of the day, I need to make sure that they are of the same size. And then I'm going to allocate now. So I'm going to go through all of the rows first because that's how I did it. I allocated the rows first. So I'm going to start by going through the rows. R is less than underscore rows at plus plus. And then for unsigned, int C is equals to 0. C is less than underscore calls C++. And then I'm just going to say underscore voting RC is equals to obj voting dot underscore voting. So I'm going to copy all of the individual values at a time. So take the values from this object, because that's what I'm copying from, and copy it into my object. So we have that. So now I'm done implementing the helper functions. Now I need to call them. So for example, the destructor, I need to call the destructor helper function. There we go. Simplifies my code. And then for my constructors, I need to call the constructor helper functions. And the constructor helper function, I call it here. So I'm going to have rows, and then I'm going to have columns. And then I'm going to have district. Then I'm going to have constructor, which takes in rows, columns, and the district. There we go, helper function. And then this one, I'm going to chain it to the constructor that is most of the implementation of the parameter. And then here I'm going to use a default district for this one, since the rows and columns are provided. The only thing that wasn't provided is the district's default values. So that's why I'm doing it like that. And then there's our copy constructor, obj voting. I'm going to call the helper function called copy constructor, which takes in obj voting. Okay, that's pretty much it, that side. So now, okay, for the rows and columns, I shouldn't be doing this thing of using ints and ints. I should make it unsigned, because I'm never going to have a -1 row, whatever. I'm not going to have something like that. The rows and columns are always going to be positive. So I'm going to need to make it unsigned. And then I'm going to have obj voting here. Okay, I'm copying and I'm using an operator. So I'm going to use a different naming convention. I'm going to say obj right-hand side, because that's what's going on here. I'm taking a value on the right-hand side and then copying it to my object on the left-hand side. So what's the structure? This is basically what I'm doing. It's like I have int x is equals to 9, right? And then I want to say y is equals to x value. So the question that I need to ask myself is, what is the type of this? What is on the right-hand side? It's of type int. So it's of type int, and what is on the left-hand side? It's of type int. So I must have two integers on the same side. The only difference now is that the type that I'm working with is a type that I've created on my own, which is a voting grid. So now it's going to be somewhat like this. Voting grid is equals to voting grid. So which means that I'm going to have some voting grid obj grid type, something like this. Maybe it was initialized using a default constructor. And then, okay, I initialized 2. Let me say obj grid 1 using the default constructor. And then, yeah, and then now I need to say, for example, obj grid is equals to obj grid 1, something like this, right? So what is the type of obj grid on the left-hand side? It's voting grid. And then what is the type of what's on the right-hand side, which is what I'm taking in, which is what the voting grid. So voting grid is equal to voting grid. It should be equal to the same. And after doing all of this, what type do I get back? For example, after taking the value of x and putting it into y, what is now the value inside y? It's the same value. What is the data type of the value inside y? It is the same data type as the value that was stored here. So it's of type what? Integer. So that's why I need to get back a voting grid, because I am assigning one voting grid to another voting grid using the assignment operator, which is equals sign. So how do we assign? This is how we assign. So we start by making sure that I don't assign value to myself. So for example, if int x is equals to 10, like this, and int y is equals to 10 again, there's no point in doing this. There's no point. They're of the same value. So that's what I need to do. I need to check for that first. I need to avoid that. I need to avoid and make sure that they are not of the same size. So how do I do that? I use the addresses. I use this operator. Remember this operator? It stores the address of the current instance of the class. This is an address. it's some hexadecimal value, but yeah, it's an address. Remember, I'm taking this one by address, so I can compare it by address. So I'm going to compare them by addresses. So I'm going to say if this address of the object that I want to copy into, if the address of that object using this, if that address is not equals to the address of what I'm taking in, and I need to put the address of to indicate that I'm specifying the address. If it's not equals to that address, then there's no point in, then you should what? Assign. Else you should just if it either did this or it didn't, then you should just return the object itself, right? Remember that I must return the object by reference, right? So in order for me to return it by reference, I need to return the object itself, and then it's going to take the reference of that and return the reference. So how do I return the object? So I point to the address. Remember, this is some address. Let's say, for example, 46 Hilton Road. That's what is stored inside this operator. That's what is stored. So now if I want the value or that thing that's at that location, I go to that I go to that address, or I point to that address. How do I go to that address? You use the dereference, you use dereferencing or a pointer to say, okay, go to this address, 46 Hilton Road, and get that person, because that's where the object is located. So I use that pointer to go there. And then once this is done, now I'm gonna do a deep copy. How do we do that? So I start by deallocating first, and then I allocate memory. And the memory that I'm going to allocate in is to match to the memory for this object. So they need to be of the same size. So I make sure they are of the same size. So I take in the rows for that one, and I take in the columns for that one. Okay, the constructor takes in 3 parameters. It needs 3 things, right? So here I'll just use a constant that I created, default district. I'll just use that constant. And then once I'm done, now I can copy the data. Copy it from what object? obj right-hand side. And then done, I've taken a value from one object to another. And then that's all you have to do. And then for this one, the invocation operator, we're gonna need to return a district. So this is very simple, but we need to enforce the range first. Make sure that we're getting the right values. So I enforce the range, I check my row. Is it between the minimum value of 0 and the maximum value of, remember that we have the maximum rows now. We did get the rows from the user. What is the rows? It's stored under the variable underscore rows. So rows minus 1. If I start counting from 0, I will stop at the value before that value. I will stop before that value. And then column min underscore value from 0 to underscore calls minus 1. We've enforced the range. Then now all I can do is simple. I just return. So return what? Voting at what index? Row index, column index. At that specific coordinate. And then I'm done. And then I think I'll implement the 2 operators, the 2 functions, this operator function and the toString function. Then we'll continue in the next part 3, for we'll continue implementing these 2 functions. So let's implement this operator. So what this operator is supposed to do is very simple. It's supposed to, okay, the size stays the same. I don't change that. The grids, IDs, they stay the same. So that means I'm iterating through, when I start talking about the rows and columns stay the same, that means I'm iterating through the array. So I need to do for loops. So unsigned int r is equal to 0, r is less than underscore rows, r plus plus, then for unsigned int c is equal to 0, c is less than underscore calls, c plus plus, and then now I need to look at what should change. So the population should be set to 0. So remember that voting is a record structure, right? So I need to say dot district I dot the population dot population is equals to 0. I need to set it to 0. And then the support percentages for the two parties are set to 0. So for the two parties, the APU and the other one are set to 0. Dot APU support is set to 0. And these are real values, so I'm gonna say 0.0. Voting RC dot UAP 0.0. There we go. And then they said the other one should be 100. The undecided should be 100. So underscore voting row column dot undecided should be 100, and it's a double, so 100.0. And then that's all you had to do. I feel like this is the best way to implement it. You don't have to return anything. You're not gonna do anything without you've returned. And then let's see if I should do the analyze now or in the next session. Let me see. Okay, I haven't built the project yet. Okay, exited with 0. Okay, let me plug in the charger. So let's see. So let's see, enforce range, down. Okay, let's look at the analyze and see if it's something that I should do now or I should do it in the next session. Let's see, where is it? The analyze function. That will return a string representation of the grid. The voting grid delegates its own analyze method contained. The voting analyzer should do that. Okay, so before we continue, I forgot to manage the life cycle of this contained class. So we need to manage that life cycle. So when I allocate the object, I should also allocate memory for, I should also instantiate that object. So inside my constructor helper method, that's where I'm gonna say is equals to new voting analyzer. Unimplemented, oh yeah. Yeah, I remember. I remember now. You can't remember you can't instantiate the incomplete classes. If it's an abstract class, you can't instantiate. So I'm instantiate the children. Delegates, it manages this, or it manages the life cycle of the voting analyzer objects. So it manages life cycle of the voting analyzer objects, not the object itself. So let's see how we're supposed to manage it. The method must now polymorphically call each of the contained voting analyze functions and return their combined output. So must polymorphically, yeah, I understand. But now the thing is we can't instantiate voting analyzer here. Since it has a virtual function or an abstract, it has an abstract function. So basically, voting analyzer is abstract. So what I would suggest, let me check. Okay, it doesn't have. I think you can use, let me see, type. Let me see, what function can we use here? Or should I just check? Let's see. Which implement the analyze method that return a straight representation has a collection of one of each of the voting analyze. Oh, so it has, okay, they made it actually very simple. Because what I was thinking of checking what type the object is. That's like sort of the correct way of doing it. And then if it is of certain type, then you could instantiate it. So let me just check something here. There's this key. I don't know if it has. I'm not sure if C++ has. Can be achieved through dynamic cast. Well, it becomes very complicated when you dynamically cast. So let's not get into that. No wonder why they just say just create instances of that class. So in essence, what they're saying is that you should create the analyzers themselves, the children themselves. So I should say battle, ground, analyzer, pointer, and then say battle, ground. And then obviously we must import, or else it's going to keep moaning at me. Let's remove voting analyzer because we're not going to need that. And then I'm going to have potential rod analyzer pointer potential rod. Then import, and then I'm going to have predicted outcome analyzer underscore predicted. Okay, so let's instantiate the object. Instantiate the objects. They say they should manage all of the objects, so we should instantiate all of them one at a time. So battleground is equals to new battleground analyzer. There we go, done. Underscore potential fraud is to new potential fraud analyzer. Then underscore, what's the other one again? Predicted outcome is equals to predicted outcome analyzer. So there we go. We've instantiated the objects one at a time. And then we also need to deallocate. So I need to go to the distractor helper function and then also deallocate the objects. So delete the objects basically, underscore battle ground, then delete underscore predicted outcome, then delete underscore potential fraud, and then all of them I set them to null pointer underscore predicted outcome goes to null pointer underscore potential fraud goes to null pointer. There we go. We've managed the life cycle. So we are sorted with that. And now the important thing is the analyzer function. They say you should implement it in a wild way again. Must now polymorphically call each of the contained, must now polymorphically call each of the contained voting analyze functions, and return their combined output. So we must return their combined output. So this is gonna be somewhat of a tricky thing, but let's do it. So string stream SS, and then at the end of the day, I'm gonna return a string representation of the string stream. So .str. So we need to call the functions polymorphically. So how do we do that? So I need to do this. Remember that this is how you do it. You use the point itself, the object, the instant of the object, and then you do that. So let me just show you how we would normally do it. We would normally do it like this, right? You say underscore battleground, right? And then you say analyze, and then you pass in the object that you want to perform the work for. Remember, we're taking it by reference. So this we need to, in order to take a reference of something, remember this is already a reference. If you're passing a reference, how is it going to take the reference of that object when you're passing a reference? So you need to pass the object itself, then it's going to take the reference of that object. So that's why we have to dereference to or point to the address or go to the address, because we want the object itself. We pass the object, but then it's going to take the address of that object. So keep that in mind. I know that this operator returns an address. I know, but you should be returning an object itself so it can take the address. So remember, when you usually do this, we say return. What are we returning? Whatever is returned by this function, which is going to be some string, right? So it's exactly the same thing. So remember that with string stream, you say push in a string like this. And then you can even push in a new line character can do that. So with that being said, this function is going to return a string. So whatever is returned here, dereferenced, I'm going to push it into the string like this. And then I'm going to do this. I'm also going to push a new line character. And then I'm going to push potential fraud, analyze, dereferenced using this operator, and line, then SS. What's the other one? I think those starts with the P, predicted outcome. Analyze, dereferenced, and new line character, like this. So this is what they mean when they say combine them. So we're gonna do it like this. You can remove this new line character, but they won't be formatted the right way. We don't want it to be like that. We want it to be formatted in the right way. So we have our string stream, and then we insert the strings into the string stream, and then we return a string representation of that string stream. Or we return one value instead of an array or a stream of values, because this function is mainly meant to return what? One string. So yeah, that's how we implement it. In the next recording, on the next part, we're gonna do the reading from the file, saving to binary. That's it for now. See you in the next video.